All right, hello everybody. This is OSS week one or March week one, and here's our demo for the week. First off, we got David showing us some CI stuff.
We've got a preview repository here where we've put some of our code and trialed out some GitHub actions. Here's an example of a pull request that has a bad commit. You can go in here and you can see it's failing. If you go to get more details here, you can see it's missing a semicolon and points you where to go to fix that. Here's another pull request that has a bad test. You can see it's compiling. But there's a test that has failed. You can click here for more details, and you're getting the specific test that's failing and a stack trace if you want some more info. And then we've got some other pull requests here that are awaiting review, but otherwise are passing checks, and so ostensibly are ready to merge. We've also got a build that runs every time anything hits main, and it's building 4 different Docker images here: gRPC API, gRPC proxy, Envoy, and web. And you can see the breakdown of the times right here. We might ask the question, why is web taking 12 minutes here? And we've got Gradle build scans enabled, so we could jump over to one of those. And you can see about 1/3 of the time here is taken up by an npm production install, and about 2/3 of the time is taken up by this IDE client task. And so that might be a place to look into to see if caching is not working or if they're just slow tasks.
Yep, perfect. And on that note, so for this week, I was working on optimizing the build time for the web and cutting out unnecessary stuff. So that build time should be reduced about 25% by the time we actually get going on the OSS stuff. All right, Corey, let's see what you got.
All right, so I need to present my window first. Sorry. So this is the C OpenAPI client, and this comprises both the sort of high-level and low-level interfaces to the API interface. But what's new is that all of these examples are working. And the thing that I would like to, and these examples cover kind of a wide gamut of the kinds of API calls we make to the server. And one thing I'd like to highlight is the fact that the main program is actually quite simple. I do very kind of straightforward calls like connect, login, start worker. Hopefully these highlights are showing up on your screen. Mm-hmm. And I will just jump into this is an example that drives a bunch of specific examples, but I will drill into the filter example for a second. What I'm doing here is just calling, like literally getting one of our demo tables and calling where on it. And this example is meant to show 2 different things. It's meant to show that we can access the database in kind of the iris style, meaning I can pass a where clause that would look very much like the thing that you would type in to to an iris console, or I can do the identical query semantically in the so-called fluent style, which means that I use kind of programming language constructs to express the same thing. So like this, what I mean to say is that import date, ticker, close are symbolically represented in the program as kind of Deephaven colons. And it means that this kind of expression here that I'm highlighting, that I passed the where clause, is kind of parsed by my compiler locally, and it won't, if I make a mistake here, make some kind of syntax error, that my program won't compile, and that's really nice. If I make a query syntax error, I don't have to wait to run my program, my potentially long-running program, before I see that error. I would see it here. So just as a simple example, if I put like, 2 extra parens here, it's not going to compile. Or if I try to compare a string, with an integer, it's not going to compile. Stuff like that can be very helpful to the programmer.
Yep.
And again, like and just highlight, I find it personally pretty pleasant to program in. There isn't a lot of setup or registration or complicated kind of cargo cult stuff that the programmer has to know. I think it's pretty easy there's a line by line correspondence
Yep.
between what they want to do and what the library does.
Yep. Very cool stuff. All right. And last up, we have Christian.
Oh,
Christian, you're muted. Sorry.
Sorry. Now I'm not muted. Hi. So we have had a couple of index changes recently, and one thing that I did this week was begin to work in a few small type benchmarks to ensure that the changes that are supposed to help with memory utilization actually are not making us slower, which would be pretty horrible. And apparently not, and I have something to show there. I am going to do that now. Clickety, clickety, click.
Beauty.
So this window here is showing a GMH benchmark. It's called small index creation. This is creating a small index. And creating an index is one of the things that you can do, right? There are many other possible actual operations you can do things with the index, but creation is an important one. This is the typical structure for a GMH benchmark where you set up a certain set of values. We are doing here some work to really create like a sprinkled around set of values per one of our blocks for the regular space partitioning RSP index. And if I were to run this, you will see the benchmark getting samples and like rounding some errors and figuring out a good value to show in a final table representation, which shows up when it ends, that looks like this. And here we can see that for the thing that actually we care about, which is sorted ranges int capacity here. Sorry, I have the wrong one here. We can see the score 0.26. It compares nicely with the base score for creating the index manually, which is around 10 times bigger. And there is a kind of like very base level case here, which is if we just use an array of longs, so there's no index, there's no complex operations that you can do. We're just storing individual values in the array. That is super fast. And of course, it will not do because we don't have an index. But it's a good way to have a floor. We can never do better than this kind of thing. So we are 5 times slower than an array, which for the level of functionality that we provide, I think is not bad. And we are 10 times faster than the no specialized case. So I think we're good.
Yep. Very cool. And that's going to be cool once we tie it into CI, and then, your changes will be checked before you're able to merge them in to make sure that we're not slowing everything down.
We are totally shooting in that direction, and that work has not happened yet.
Yep. Beauty. All right. Thanks, everybody. I hope you have a great week.